Oh my god, Lewis structures are so complicated. I swear I'm gonna fail this chemistry exam.
Hello, Tom. I hear you're struggling with Lewis structures, but I want you to know that Lewis structures are the roots of the tree of chemistry, and you need to understand them before you can do anything else and move forward in your chemistry career. So I can help you get an A on your exam.
Really? You can do that?
As long as you're willing
Thank
to
you so
complete a
much.
few challenges. Are you in?
I guess so. I have no other choice.
Welcome to your first challenge. The first thing you have to do is draw the Lewis dot structure for CH4.
Okay, so CH4.
Right.
I know how to write the formula, but I'm not sure what else to do.
Alright, well the first thing you have to do is calculate the number of valence electrons. Do you know how to do that?
I think so. So carbon's in group 4A, so it has 4 valence electrons.
That's right.
And since hydrogen has an atomic number of 1, it only has 1 valence electron for each hydrogen.
Right. So now...
So 4 plus 4 is 8. So 8 total valence electrons.
Good job. Now, do you know what to do?
No.
Okay. Well, now you can write the skeleton structure of the molecule.
And how do I go about that?
So, the central atom is going to be the least electronegative. So
that
what
would
do you
be
think's the least electronegative one?
Carbon.
Right.
Okay. And then there's going to be 4 hydrogens on the outside.
Right. So now you're going to distribute the electrons to the atoms surrounding the central atom, which is the carbon, to satisfy the octet rule.
Okay, so with each single bond, there's 2 electrons that are shared between both of the atoms.
Right.
So if I draw 4 of these single bonds, carbon would have 2 electrons from each, meaning 8 in total, fulfilling the octet rule. And since hydrogen's an exception, it only needs 2 electrons. Each hydrogen has 1 bond, which is 2 electrons, so it fulfills all the rules.
Perfect. So now would there be any lone pairs in this structure?
No, because the 8 total valence electrons are all accounted for with the 4 bonds.
Right. Good job.
This is your second challenge. Draw the Lewis structure for POCl.
Okay, so POCl3. P, phosphorus, has 5 electrons, plus 6 for oxygen. These are valence electrons. And then 7 times 3 for the chlorine, which total is 32. Okay, so you draw P in the center with a CO, 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 O. I don't know why that O is so big, sorry. And then a single bond to each one, which gets rid of 8, which is 24. And then you just draw the dots on all of them to fill the octet rule.
Aren't you forgetting something?
Is that right? Wait, what am I forgetting?
There's gonna be a double bond on the O.
Oh my gosh, this is so complicated. If I don't do well in this chemistry exam, there's no way I'm gonna get into medical school, and then I'm gonna be screwed for the rest of my life. This is awful.
No, it's okay. You'll learn. So,
Okay, so what do I need to do?
you need to think about formal charge.
Okay, so how do I really don't even know what the formal charge is.
Formal charge is valence electrons minus lone pairs minus half of the bonded electrons.
Okay, so for chlorine, it would be 7 minus 6 for the lone pair electrons minus 1 for half of the bonding electrons equals 0. So all of these have a lone charge of 0.
Mm-hmm.
And phosphorus has a lone charge of 5 minus 4 equals 1, so plus 1. And O has 6 minus 6 minus 1, which is negative 1. So is this why it's wrong?
Yes, you need to have a double bond on the 0.
Okay, so I could cross off this valence pair and write a double bond here like that.
So what would that change? How would that change the formal charge?
Then this one would be 6 minus 4 minus 2, which is 0. And P would be 5 minus 5, which is 0. And then they'd both be 0, so it'd be balanced.
Right, and the sum of the formal charge is going to be the charge of the total atoms.
Perfect. So since this is a neutral molecule, now you have all zeros, so it's a neutral molecule.
Congratulations, Tom. You're going to get an A on your exam now. I've taught you all you need to know about Lewis structures.
Thank you so much. I'll be forever grateful.
And now, I'm going to teach you how to Dougie.
And brought it to the hood and got the